Good evening, guys. I welcome you all to today's discussion. And in the previous discussion, we've looked at how to derive your indirect utility function and how to also derive your expenditure function. And in deriving your utility function, we were able to derive our Marshalling demand functions too. And the same thing applies to when you have your expenditure function. You can as well use the Shepard-Lemma rule to also derive your Hickson demand function, which I did in the previous one, right? So today what we are going to look at is what we call the duality concept. So somebody may ask, so what if you have this question in exams and you've been able to derive your indirect utility function and they ask you to also find your expenditure function? Does it mean I'll have to go and start the whole process again and set up my Lagrangian and differentiate respect to x1, x2, x3, and a whole lot of stuff before I get my expenditure function? The answer is no. There's that kind of relationship between the indirect utility function and that of the expenditure function. So what it means is that if you have your indirect utility function, you should be able to derive your expenditure from it without necessarily going through a lot of processes by differentiating and other things. And the same thing applies to when you have your expenditure function. When you have your expenditure function too, you should be able to derive your indirect utility function from the expenditure function, right? So today, that is basically what I'm going to look at. So I'm going to quote the previous indirect utility function and that of the expenditure function we got, and we will take them one by one and we derive the other ones from it. So what we call this in economics is called the identities. So I'm going to use the identities to derive one function from another function. It's okay. So let's quote our indirect and then the expenditure function from the previous discussion. Okay, great. So these were the expenditure functions, indirect utility function, and that of the Marshalling and demand function that we got in our previous discussion. So the first one, which is this one, represents our expenditure function. This one represents our indirect utility function. This one represents our Hickson demand function, which is a function of P and U. And we have this one also represents our Marshalling demand function, which is a function of P and then Y. So this one here means X is a function of P and Y. So let's start with the identities. First, I will start with write my identities. If you remember, we said something like the expenditure function that we have, which is a function of U, P and U, should be equals to what? Y, right? That is your expenditure that you are going to incur should be equals to your income. You can't spend more than your income, right? It should be equals to your income. So when you maximize the optimal X1 and X2 that you get, when you fix that into your utility function, that gives you what? A V. So when you fix in your optimal X1 and that of X2 into your utility function, right? That should be equals to what your V, which is a function of P and Y, is okay. When you replace your optimal X1 and X2 into your indirect utility function, that gives you a V, right? So that means what it means when we maximize that, then I can say this expenditure function here, which is a function of P, is the same as V P of Y, which is equals to Y. Is okay, which is equals to Y. Great. Now the same thing. We also said, so this is first one of the identities that we are going to. Okay, so let me use this into one of the identities. Great. That we are going to use, right? So this identity one. Now the second identity we have, we also said V, which is a function of what? P and Y is also equals to what? U, right? That's when you fix in your optimal X and Y in your utility function, that gives you this, right? But we also know that always our Y should be equal to what? Our expenditure, right? So then I can say this V is also the same as P. Instead of Y, I'm going to write E P, which represent the expenditure, right? Equals to U. So I'm going to call this identity 2. Is okay. So basically what we are doing is that we have this as our expenditure function equals to our y, right? And we said expenditure is a function of P, prices, and then utility, right? And we said when we solve our optimal x1 and x2 and we replace that into our direct utility function, what we obtain is what we call the maximum utility, right? So when you replace that into that, what you get is the same as the indirect, which is V. So that means in place of this U here, I can write this V P of Y, right? Which is equals to Y. So that's what I've done here. And when I come to my V, the indirect utility too, we said that when we replace x1, x2, that gives our V, right? And that should be equal to the maximum U here. Is okay? So in this case, now we also know that always our Y, our expenses should be equal to what? Our Y. All right? It should be equal to your income. So that means in place of this Y, I can write this, right? So great. Now, so let's say we have, let's look at this example. Let's say we have our fee. You go to exam source and you've been given this indirect utility function, Vy is equals to, let me quote it from here, Vy is equals to Y into brackets P1 R plus P1R plus P2 R negative 1 over R. Great. So when you have something like this, and you are asked to find, let's say you've been asked to find the expenditure function from this. This is your utility function. You've been asked to find the expenditure function from this. Now, how do I know my expenditure function, right? So I'll have to go to my identities. Now, the identity says that when I have V, P, which is a function of P and Y, then I can say V, which is a function of P and Y, the same as what? Which is a function of P and U, right? P and U should be equals to what? U. Is okay. It should be equals to U. So what it means is that wherever I see Y in this expression, right, I replace it with U, EPU, right? So that means when I look at this expression here, I'm going to change this. I will have Y instead of Y here, I'm going to write E P U multiplied by P1 R plus P2 R negative 1 over R equals to what? U. Is okay? Then because I'm looking for expenditure function, I make this the subject. So I'm going to have E P U is equals to U over P1R plus P2 plus P2R negative 1 over R. Is okay? Negative 1 over R. Great. Now this can also be simplified as what? Yeah, mathematics. When I bring this one up, this one becomes positive. It can be simplified as U into brackets P1 R plus P2 R, and I have 1 over, sorry, no negative because it is now moving up, and it becomes 1 over R, right? So that means this is the same as this represents the expenditure function. So let's compare this with the expenditure function that we got when we tried to differentiate using the long approach, which we quoted, right? So you can see this, what we've gotten right now, is the same as this one. It is the same as this one, right? So that means when you have your indirect utility function, by using the duality concept, you should be able to derive your what? Your expenditure function from it. And the same thing applies to when you have the expenditure function, you should be able to derive your utility function, right? So let's start again with that one. So let's say we have expenditure function as EPU, right? Which is equals to, let me write it, U P1 R plus P2 R 1 over R. Great. So this is our expenditure function. Now with this our expenditure function, we can also be asked to find what our indirect utility function from this, right? So we know that we said expenditure function, right, should be equal to what? Y. Now in place of this, you can replace it with what? V or Y. V with the function of P and Y. So I say this is equals to P, and then instead of U, I write V with the function of P and Y. Is okay, and it should be equal to Y, right? So okay, so what it means is that wherever I see U in this equation, I'm going to replace it with V of Y, right? So I'm going to have, instead of u here, I'll have v p of y is okay. It's equals to, sorry, v p of y multiplied by p1 r plus p2 r 1 over r is equals to y. Is okay. So I'm looking for v of y. So just divide both side by this part, then that will give me equals to y over p1r plus p2r 1 over r, right? Now, because it is mathematics, I can bring this one up and become negative. That will give me y into brackets p1r plus p2r minus 1 over r. So this now becomes what our indirect utility function. And we are getting this indirect utility function from our expenditure function. So let's compare this with that of the one that we quoted to see if the same thing. So when you compare, you see they are the same. The indirect function that we had here is the same as when we tried to derive it from what? We tried to derive it from the expenditure function. Now the second identity is also saying that when we know our the Marshallian demand function for x1 or x2, then we should be able to derive our Hickson demand function too. So what it means, the identity says that the x that solves the Hickson demand function, which is a function of p and u, should be equal to the x that solves the Marshallian, which is equal to p and then y. So depending on which one is given, you should be able to find the other one. So let's look at the situation whereby I could, yeah, great. So let's say we have a situation whereby we know our, let me look at it again. So let's look at the situation whereby we know the Hickson demand function. Oh, sorry, let's look at the situation whereby we know the Marshallian demand function and we've been asked to look for the Hickson, right? So let me quote first the Marshallian demand function again. The Marshallian demand function, let me quote it. We had x1, great. So we had, supposing you are only given x1, which is a function of py in exams, and we say it's equals to p1 1 over 5 minus 1 y is okay, all over p1 5 over 5 minus 1 plus p2 all over 5 over 5 minus 1, right? You have something like this, and you are asked to find the Hickson demand function from this, right? So you don't have to go and look for your expenditure function and then set up your Lagrangian, minimize your expenditure function, and then you get your Hickson demand function, which will take a long period of time, right? But once you know your Hickson, you know your Marshallian demand function, you should be able to find your Hickson, right? So what you write is, first I'll start with we say x Hickson is equals to p with a function of what? U is okay. When we are saying that that is identical to what? X, which of a function of what? P and then y. But we know that the y is always equal to what? Income. So I'll say instead of y, I'll write E P of what? U is okay. So then what that means, wherever I see y in the Marshallian demand function, I'm going to replace it with what? EPU. So that means I will have the function, for instance, as P1 over 1 over P minus 1. 5, that is 5 over 1 all over y. So sorry, instead of the y, now I'll write all over. So I'll make here p1. So this is going to be p1 5 over 5 minus 1 yeah, all over p2 5 over 5 minus 1, right? Multiplied by the y. Now because of the y, we are now going to write it to what? EPU. And the EPU has been given already in the question, right? EPU has already been given in the question. So I'll just look at what we got for the EPU. So the EPU, we got the EPU to be great. The EPU was, so the EPU was, so I'll write it again. So I will say that X is saying with the function of PU is equals to P1 1 over 5 minus 1 all over P1 5 over 5 minus 1 plus P2 phi over phi minus 1 multiplied by, so instead of the y, we are going to replace it with all the exponential function. Now the exponential function is given. So once we write the exponential function was u multiplied by P1 R plus P2 R all over what? 1R. Great. Now, so if you remember, in the previous discussion, we said R was equal to what? Phi over 5 minus 1. If that's the case, then when you subtract 1 from here, you subtract 1 also from here. That means R minus 1 is equals to 1 over 5 minus 1. Is okay. So then instead of this, I'm going to write this is the same as what? P1 R minus 1 all over P1 R plus P2 R is equal multiplied by U into brackets P1 R plus P2 R 1 over what? R. Great. Now look at something. This expression here and this expression here had what? The same base. So this is like also up to exponent what? 1. Is okay. So that means, let me clear this part and write it here. Yeah, great. So that means I'm continuing from here. I can say that if that's the case, then I can say this one is same as is equals to P1 R minus 1. Sorry, the minus here. Multiply by P1 R plus P2 R into bracket 1 over R. Because it's here, when it crosses up to the numerator, but it becomes minus 1 multiplied by U, right? So this expression is the same as what? 1 minus R over R. So this expression is the same as 1 minus R all over what? R. Great. So now this becomes what? The Marshallian, becomes the Hickson demand function for X1, which is a function of what? Which is a function of prices and utility. So that means X Hixian, which is a function of prices and utility, right? Great. So how do we get this? We got this by just what? Using the identities. Is okay. So this is the situation whereby you've been given either the indirect or the machine demand function, and you've been asked to look for exponential function or the Hickson, right? So in other way around too, you can also use the Shepherd lemma. Anytime that you have an exponential function, anytime that you have an exponential function and you are asked to find the Marshallian, you are asked to find the Hickson, right? You can differentiate. We have a theory that is Shepherd lemma's law. You can differentiate your exponential function with respect to the PI that you're looking for. So let me code this one again. So the exponential function that we had was what? EPU, which is equals to U P1 R plus P2 R 1 over R, right? So if I'm asked to calculate for Hickson demand function and I'm only given this, then simply apply or the Shepherd lemma theorem, which says that anytime that you are looking for the Marshallian demand function, is the same as the X H of P U of I that you're looking for, is the same as differentiate the expenditure function with respect to P of I. So let's say if I'm looking for X1, then X1 is what? X1 PU is like differentiate the expenditure function P of U with respect to P1. Is okay. Now when I do that, so this is the expenditure function. So if I want to differentiate, I'm going to have 1 over R multiplied by U into bracket P1 R plus P2 R 1 over R minus 1, right? Then multiply, then I differentiate this one here, which gives me R P1 R minus 1, right? So this R cancels this R. So this expression is the same as what? 1 minus R over R. So I have it as what? U. So let's say this is the same as U into bracket P1 R plus P2 R1 minus R all over R multiplied by P1 R1, right? So this is all the expanded Higgs demand function for X1. And let's compare that with that of the Marshall when we use identities, right? So it is the same as this one, right? So when you check, when we use the identities, this is what we got as what Marshall Higgs demand function for X1. And it's the same as when we applied the Shepard-Lemons theory to differentiate the expenditure respect to the P1, right? So what it means is that when the question is given to you, there are so many approaches that you can use. You don't have to go back and use the previous approach that I did by differentiating respect to X1, X2, S3, lambda, and what have you. No. When you have the indirect utility function, you can derive your expenditure function from it. When you have your Machiavellian demand function, you should be able to derive your Hickson demand function from it. And the same works for the other way around. When you have Hickson, you should be able to also derive your Machiavellian demand function from it. Great. So I'm going to end here with today's discussion. And in my next discussion, we are going to take a complete question, then we solve it from deriving our Machiavellian. We take our time. After that, we look for our indirect utility function. Then we also apply the these theories or the concept again, the duality concept, to derive the other when one is given. Is okay. So thank you. Please do not forget to subscribe to my channel and watch out for quality discussion or tutorial. Thank you.